Before we dive right in, a few disclaimers. This video does not promote Nazi ideology or beliefs. It strictly focuses on the technological aspects of the era for educational purposes. We condemn all forms of hate, racism, and discrimination. Any interpretation suggesting otherwise is incorrect. The goal is to foster understanding, not controversy. Let's keep discussions respectful and grounded in facts.
Hi, this is the Amateur Analyst, keenly analyzing topics from the back rooms. Take it with a pinch of salt till your kidneys can't take it anymore.
How Nazi German tech won the future? Well, in the shadows of history, there lies a peculiar paradox, a tale of innovation born from darkness, yet quietly shaping the light of modern civilization. During World War II, as Allied forces pushed back against the tide of Nazi aggression, they often dismissed German advancements as nothing more than Wunderwaffe or wonder weapons, or also known as fanciful dreams of mad scientists and megalomaniacs. An example is the V2 rocket, which was thought to be a pipe dream that would never hit its target. The Me-262 jet fighter, overcomplicated nonsense compared to the rugged reliability of American Mustangs or Soviet Yakovlevs. The mysterious Tiger tank, an over-engineered beast, too expensive for practical use, and let's not forget the Enigma machine, just another glorified typewriter, if so. But here is where things get interesting. While those so-called wonder weapons were laughed off during the war, it didn't take long after the smoke cleared from those same critics to realize their true worth. In fact, many of the technologies derided by the Allies in the 1940s became the foundation of modern military might. Today we find ourselves surrounded by echoes of Nazi Germany's engineering genius. The rockets that launched humanity into space, the jet engines powering commercial flight, the radar systems guiding our aircraft, and even the highways connecting cities across continents. Yet, despite this undeniable legacy, Nazi Germany's contributions to science and technology remain underappreciated. Why? Because people struggle to separate brilliance from brutality. It is easier to dismiss these innovations as mere extensions of an evil regime rather than confront the uncomfortable truth. Some of the most groundbreaking ideas in human history came from one of the darkest chapters in it. Critics love to point out how Western simplicity triumphed over German complexity, like how mass-produced Sherman tanks beat Tigers, how Spitfires outlasted Me-109s. But what they fail to acknowledge is that today's militaries have evolved toward designs inspired by those very over-engineered marvels. From stealth bombers to cruise missiles, from high-speed jets to advanced encryption systems, the DNA of Nazi-era technology runs deep within modern arsenals worldwide. This documentary is meant to explore this irony head-on. We will dive into the stories behind 20 crucial technologies developed during Hitler's Third Reich, not just the machines themselves, but the minds that created them, the battles they influenced, and the ways they've shaped the world as we know it today. Along the way, we'll challenge conventional wisdom about why certain designs succeeded and others failed, revealing how perceptions can shift when ideology gives way to pragmatism. So buckle up, because this isn't just a journey through time. It's a reminder that progress doesn't always come wrapped in pretty packaging. Sometimes it emerges from the ashes of destruction, forcing us to grapple with questions about morality, ingenuity, and the cost of advancement. After all, if you think the Allies won the war purely on grit and gumption, well, maybe you should take a closer look at your car, your phone, and yes, even your favorite spy thriller. You might be surprised by who will build the future. Number one, of course, it would be a crime to start this list without the famous V2 rocket, invented by Werner von Braun in 1942 in his team of scientists. The V2, I can't say its full name, forgive my German, was the world's first long-range guided ballistic missile. It used liquid propellants, ethanol and liquid oxygen, and could reach altitudes of over 80 kilometers. It was used against London and other European cities during World War II. Modern adaptations became the basis of modern rocket science, including NASA's Apollo program and intercontinental ballistic missiles, ICBMs. The V2 was a liquid-fueled ballistic missile powered by an ethanol water and liquid oxygen mixture. It reached speeds of over 3,500 miles per hour, Mach 2.8, and could travel up to 200 miles, delivering a warhead weighing approximately 2,200 pounds. Its guidance system used gyroscopes for stabilization and radio signals for course corrections. Werner von Braun was once quoted saying, "The rocket worked perfectly except for landing on the wrong planet." The V2's development marked the beginning of modern rocketry. Despite its destructive purpose, it laid the groundwork for space exploration. After the war, both the US and Soviet Union captured V2 technology, which they used to develop their own missile program, and for the US, its own space program. We all know that. And at number 2, we have the jet engine, which was independently being developed by two different scientists. One, a German scientist, Hans von Ohen, and a British scientist, Frank Whittle. Though the German scientist was the first to implement it practically in the Heinkel HE-178, which was the first aircraft to fly with a jet engine. It was later employed in the Messerschmitt Me-262, the first operational jet fighter. Modern adaptations. Jet engines are now standard in commercial and military aviation. You can read more about jet engines in The Jet Pioneers by John Wilkinson. Technical aspects. The Heinkel HE-178 was powered by the HES-3B engine, producing about 1,000 pounds of force of thrust. The Messerschmitt Me-262, the first operational jet fighter, used Junkers Jumo 004 engines, each generating around 1,980 pounds of force. Hans von Ohen is quoted saying at one point that it was a dream come true to see the HE-178 fly. I don't know which year he said that exactly. The introduction of jet engines revolutionized aviation. The Me-262 was faster than any Allied aircraft, but came too late to significantly affect the outcome of the war. Post-war, jet technology became standard in military and commercial aviation. At number 3, we have the Autobahn system, invented by Konrad Adenauer. Forgive my name system in German, which was invented in the 1930s. It's a high-speed road network designed for efficient vehicle travel. It facilitated troop movements during World War II. Modern highway systems worldwide rarely took note from the Autobahn system. Some technical aspects. It was designed with wide lanes, gentle curves, and no intersections. The Autobahn allowed vehicles to travel at high speed safely. Initial plans called for a network spanning thousands of kilometers. Adolf Hitler, forgive me for quoting him, once said that the German road network must be the best in the world. Indeed, he was right at the time. Some additional notes. The Autobahn was initially conceived as a means to boost employment and connect major cities. During World War II, it facilitated rapid troop movements. Today, similar highway systems exist worldwide, though very few match the Autobahn's lack of speed limits. We all know that one. At number 4, we have the Enigma machine, invented by Arthur, I reconcile the second name, SCHERBIUS, in the year 1918. Well, it was commercialized in the 1920s and adapted for military use in the 1930s. Technical data. It was an electromechanical rotor cipher machine used for encryption. It was used to send encrypted German military communications all over. Modern adaptation influenced modern cryptography and cybersecurity. If you want more information about it, you can read more about it from a book called The Code Book by Simon Singh. Some more technical aspects. Using a series of rotors and blackboards, Enigma created complex cipher patterns. Each rotor had 26 possible positions, and the machine could generate billions of potential combinations. The guy who later designed the machine to crack it, Alan Turing, was quoted to say, breaking the Enigma was like solving 1,000 puzzles simultaneously. Although effective, Enigma's complexity was also its downfall. Allied cryptanalysts, notably at Bletchley Park, exploited design flaws and operator errors with cipher messages, providing critical intelligence during the war. At number 5, we have U-boat technology, invented by various naval engineers, notably Carl Dons in the 1930s. These were submarines with advanced snorkel technologies and improved torpedoes. They were used in Atlantic campaigns during World War II. Modern submarine design and stealth technology under the sea was mainly influenced by these U-boats. U-boats incorporated advanced snorkel technology, allowing them to remain submerged while running diesel engines. They also used electric motors for silent propulsion when necessary. Carl Dons was once quoted saying, "The U-boat is the weapon of the future." And boy, was he right. Indeed, he was so right, because modern nuclear submarines rule the seas. German U-boats were highly effective in the early years of World War II, sinking millions of tons of Allied shipping. Later models like the Type XX-1 or the Type 21 featured streamlined hulls and greater battery capacity, influencing post-war submarine design. Number 6, we have the Wasserfall missile, invented by Werner von Braun's team again in the year 1941. It was a surface-to-air missile capable of intercepting high-altitude bombers. It was tested but not deployed extensively due to the war's end. Modern adaptation. It was the basis of modern SAM systems like the Nike Hercules of back then. Some sources, you can read about it more in a book called The Rocket and the Reich by Michael J. Newfield. Some more technical aspects. Wasserfall was a surface-to-air missile designed to intercept high-altitude bombers. It used a liquid propellant rocket engine and radio guidance. Though never deployed in significant numbers, Wasserfall demonstrated the feasibility of guided anti-aircraft missiles. Its technology influenced later systems, including the American Nike Ajax. Werner von Braun was once quoted saying, "Wasserfall was our answer to the Allied bomber fleets." Next, we have the Me-168 Comet, invented by Alexander Lippisch in the year 1941. It was a rocket-powered interceptor aircraft capable of speeds of over 700 miles per hour. It saw limited deployment against Allied bombers. Modern adaptation. It influenced high-speed aircraft design. It was powered by a Walter HWK-109-509 rocket engine. The Me-163 could reach speeds exceeding 700 miles per hour. However, its short flight time and volatile fuel made it very challenging to operate. Despite its limitations, the Me-163 was the fastest operational aircraft of its time. Its design principles influenced later high-speed aircraft, including the X-planes of the Cold War era. A test pilot, Heini Dittmar of the Me-163, was once quoted saying, "Flying the Comet was like riding a meteor." At number 8, we have the FUD-200 Hohen 12 radar, invented by the Telefunken Company in the year 1942. It was a long-range maritime radar system which was installed on U-boats for detecting enemy ships. One of its modern adaptations is that modern maritime and air traffic control radar systems still use tech that was brought forward by this radar system. Operating on a frequency of 420 millihertz, the FUG-200 had a range of up to 80 kilometers and could detect ships and aircraft. It was one of the first practical maritime radars. A Kriegsmarine officer was once quoted saying, "Hohenzollern gave us eyes in the dark." End of quote. Hohenzollern greatly enhanced German naval capabilities, allowing U-boats to locate and track enemy vessels more effectively. Modern radar systems owe much to this pioneering technology. At number 9, we have the famous Gustav cannon, invented by engineers at Krupp in 1941. It was the largest caliber rifled weapon ever used in combat, firing 7-ton shells. It was used to bombard Sevastopol during Operation Barbarossa. Modern adaptation. It influenced supergun concepts and artillery design. Weighing up to 1,350 tons, Gustav fired shells weighing up to 7 tons over distances of 47 kilometers. Its massive size required special transport infrastructure like rails and its own train. Just imagine. Albert Speer was once quoted saying that it was an engineering marvel, but strategically impractical. End of quote. Used only twice in combat, Gustav proved more of a propaganda tool than a practical weapon. Nevertheless, its construction pushed the boundaries of artillery technology. It helped the others that came after it. That's the basic thing you should know about these things. We couldn't end this list without number 10, the Tiger tank, invented by Henshaw and Son in the year 1942. It was a heavy tank armed with an 88mm gun and thick armor. It was widely used on the Eastern and Western fronts. Modern adaptation influenced modern main battle tank design. You can read more about it in a book, Tigers in the Mud, by Frank Kurowski. Equipped with an 88mm KWK 36 L56 gun and thick armor, the Tiger I weighed 54 tons. Its powerful engine allowed it to traverse rough terrain. A tank commander, Michael Whitman, was once quoted saying the Tiger was invincible in the right hands. The Tiger's combination of power, armor, and mobility set new standards for tank design. Although expensive and mechanically unreliable, it inspired post-war developments in armored warfare. Well, I thought I could fit more than 10 different pieces of tech on this video, but it turns out your attention span is waning. We have to do the 10 another time. Conclusion. Before we wrap up, let's be crystal clear. This explanation of Nazi Germany's technological legacy is not an endorsement or glorification of the regime. Far from it. The atrocities committed by the Nazis are undeniable and unforgivable, and nothing in this discussion should be interpreted as anything other than a deep condemnation of their actions. Our purpose here is purely education, to shed light on the often overlooked ways in which some of the most transformative technologies of the 20th century emerged from one of history's darkest periods. It's crucial to learn how to separate the technology from the ideology. These innovations were created by brilliant minds working under horrific circumstances, often coerced or driven by ambition amidst moral bankruptcy. By examining these advancements through a factual lens, we can better understand both the potential and pitfalls of human ingenuity when untethered from ethical constraints. This isn't about excusing Nazism, no. It's about recognizing that progress doesn't always come wrapped in virtue, and that we must remain vigilant against repeating the same mistakes of the past. We encourage viewers to approach this topic critically and responsibly. If you are a historian, fact checker, or simply someone with additional insights, please share your thoughts in the comments below. Corrections, clarifications, and Further resources are always welcome. Knowledge thrives on open dialogue, and we invite everyone to contribute constructively to this conversation.